So net work done is equal to change in kinetic. So net work done is
Del kinetic energy.
very nice. Sum of work done by all the forces. So we already discussed a problem related to this. We'll do one more problem. An object of mass m is tied to a string of length L and a variable force find the work done by the force. So just read the question, take 2 minutes to solve the problem. After that, I will explain it. Anyone? Hello? Anyone?
Sir, MGH, sir.
No. No, it's not MGH. Anyone? So, anyone want me to wait?
No, sir.
So, an object of mass m is tied to a string of length L and a variable force F is applied on it, which brings the string gradually at an angle theta with the vertical. Find the work done by the force F. So here we have to find work done by the force F. Okay. So we have to apply work energy theorem. We have to apply work energy. So what is work energy theorem?
Work done is equal to change in kinetic energy.
Net work done is equal to change in kinetic energy. So what is net work done?
Work done by all the forces.
Very good. Sum of
All the forces.
work done by all the. So to find work done, we have to find sum of the work done by all the forces, right? So to find sum of work done by all the forces, we have to identify. So can anyone tell me how many forces are acting on this pendulum? The mass?
Three forces.
Three forces. Nice. Everyone agree?
Yes, sir.
There are three forces. So what are those? First one,
Normal.
Gravitational force, normal force,
Tension force.
tension.
gravitational force, tension. Third one is, what is third one?
The applied force.
Normal.
Normal force.
All right. Look here, it is variable force. So here, is there any normal force?
No, sir.
No. Okay. See, tension comes under normal force. Is it clear? So I will explain what is normal force. So see, guys, suppose when a body is on surface, when a body is placed on this surface, weight of the body is in which direction?
Minus J cap, sir.
Very good. Downward direction or minus J cap direction. Normal force is in which direction?
J cap.
Upward direction.
Upward direction.
Take up, sir.
See, we write normal force only when the body is in contact with a surface or another body. Is it clear? Then only we write normal force. Suppose when the body is hanging from a string, a body is hanging by a string. In this case, how many forces are there? How many forces are acting on the body?
Two forces, sir.
Two forces, sir.
Two. One is mg, another one is
Tension.
Tension force.
tension. Okay, here there is no normal reaction. When there is surface or when there is a contact with a surface or contact with another body, then we write normal force or normal reaction. Then if you have a spring and this is mass m, if this is a spring, this is mass m hangs from the spring. No, how many forces act on the spring? How many forces? Two forces. They are mg and
Tension force.
right. See, here we call that force as spring force. Yeah, spring force is equal to kx. Here it is mg. Just remember these differences. Next, so we have gravitational force, tension, variable force, right? So initially this is the mass m, this is string, so the variable force is something like this. So this, due to this force, variable force, the string comes like this. Like this. So this angle is theta. So there are three forces. One is now for this bob, I'm drawing force on this bob. So one force is tension is in this direction, mg is in downward direction, variable force is something in this direction. So we have how many forces? Three forces. So net work done is equal to work done by tension plus work done by weight, that is mg, plus work done by, I take here it as horizontal. horizontal. So work done by tension plus work done by horizontal force F, right? So this height is L. What is this height? Height raised by the mass mg. Anyone?
H, sir.
Very good. Right? It's H in terms of L.
H minus L, sir.
So what is this length?
L cos theta, sir.
What is this total length?
L
H plus L.
L plus H, sir.
plus L cos theta.
See, from O to A, see, this length is L. This length is, see, this length is from here to here it's L. From here to here it's L cos theta. So H is how much?
L minus L cos theta.
L cos theta.
Very good. L minus L cos theta, right? So what is this length?
L sin theta, sir.
L sin theta. So initially the body is here, right? This is initial position. This is final position. What is displacement vector?
The shortest distance from the initial and final points.
See, this is initial position. This is final position, right? This is x-axis. This is y-axis. This is x-axis. What is this distance? This distance is L.
L sin theta.
This distance
H
L minus L cos.
L cos theta.
So can I say this as displacement vector? Yes or no?
Yes, sir.
Right? See,
Yes.
it's here, it's here. So this is the displacement vector. So can anyone say what is displacement vector? S is equal to
Final position vector minus initial position vector, sir.
see, x component is L sin theta, y component is L minus L cos theta, right? So displacement vector x component is how much? L sin theta, y component is L minus L cos theta. So displacement vector is x component I plus y component j. So x component is L sin theta I, y component is L minus L cos theta j. This is displacement vector. So we have to find work done by the horizontal force, right? So work done by the horizontal force is how much? What is work done by force formula? For F dot
Yes, sir.
displacement, right? So here the applied force is horizontal force, right? So can I write F vector as Fi?
Yes, sir.
Yes, sir.
So substitute Fi here. So I get Fi dot. What is displacement vector? L sin theta I plus L minus L cos theta j. So what is the final answer? Anyone?
FL sin theta
Yeah, nice. Fl.
sin theta.
Very good. Fl. Okay. So you can solve this problem like this, or see what is work done by F force F Fl sin theta, right? Now look here, or we can do it in another way by using work energy theorem. So what is work energy theorem? Work net W net is equal to change in kinetic energy. So first we have to find, we'll find work done by tension, then we'll find work done by mg. Now look here, what is work done by tension? Tension dot displacement, right? Yeah. So here, if you see this figure, look at this figure. See, in this figure, tension is always perpendicular to displacement. Is it clear? So when simple pendulum moves like that, tension is perpendicular to displacement. So what is the angle between tension and displacement?
90 degrees.
90 degrees.
So work done by tension is
0.
0.
0. So what is work done by weight? Work done by weight is mg dot displacement, right? So minus mgj dot, what is displacement vector? L sin theta I plus L minus L cos theta j. So how much do we get from this? We get work done as can anyone see the answer here?
Minus
L
mg
into
to L,
L cos
L minus
theta.
L cos theta.
1 minus cos. So we got work done by tension as 0, work done by weight as minus mgl into 1 minus cos theta. What is initial kinetic energy? Is it starting from rest?
0, sir.
0, sir.
Final kinetic energy?
0, sir.
0.
0. So W net is equal to Wt plus Wmg plus Wf, which is equal to 0 minus mgl into 1 minus cos theta plus Wf. Change in kinetic energy is 0. So W net is equal to change in kinetic energy minus mgl into 1 minus cos theta. plus WF is equal to 0. So WF is how much? MGL into 1 minus cos theta. Is clear? See, this is work done by, this is also the work done by force F. Now look here, we found out work done by force F as FL sin theta, right?
Yes, sir.
So this is valid only when the force is horizontal. Is it clear? This is valid only when force is horizontal, then force F is Fi. Suppose in the question, if they say that this is not horizontal, this is variable. They say that this force has variable instead of horizontal, then can we use work done is equal to F dot S? See, this formula is valid only when force F is constant. Meaning magnitude of F is constant, direction of F is also constant. So when these two conditions are satisfied, we can use this formula. Suppose if they say the force is variable force, they say that the force is variable force, then either magnitude is changing or direction is changing.
Excuse me, sir.
Yes.
Please repeat once again, sir, before you.
From where?
From this, sir.
Okay. So look here, work done is equal to F dot S is only applicable only when force is constant force. So that means either magnitude of F, okay. So force F is constant means magnitude of force F is constant and direction of force F is constant. Then variable force means either magnitude of force F is changing or direction of force F is changing. In that case, we cannot use work done is equal to F dot S. This formula we cannot use it. We have to use work done is equal to integral F dot ds, which we didn't discuss. Nice. Next question. An object.
Please show the before one, sir.
So if anyone have, see, take 3 minutes, just go through this problem again. If anyone have doubts, please let me know in the chat box.
Thank you, sir.
Yeah.
Sir, could you please show me the solution of previous problem, sir?
This one.
So next page.
Sir, next page, sir.
Sir, please show another slide, sir. Next slide, sir.
This slide.
Sir,
This one.
sir, please explain that how did y component arrived, sir?
Where?
L minus L cos theta, sir.
Here, right? This one.
Yes, sir.
So see, from here to here, what is the length?
L, sir.
L. From this line to this line, L. So this line to this line length is
L, sir.
L. So from here to here it's L. What is from here to here, this line to this line?
Okay, sir. Okay, sir. L minus L. L cos theta, sir. That
So this is,
L minus L cos theta.
that's it.
Thank you, sir.
Anyone? Hello? Fine. Next. Next question is, see any, an object of mass 10 kg falls from rest through a vertical distance of 20 meters and 50 meters and attains a velocity so on 80 meters attains a velocity of so what is the velocity of the body neglect air resistance? Solve this. 2 minutes. Take 2 minutes. Try to solve this. Easy question.
Sir, velocity 28 root 2, sir, meter second inverse.
Are you sure?
Yes, sir.
Fine. Anyone?
Sir, 40, sir, if gravity is taken as 10.
Very good. Anyone?
Sir, 40.
Very good. Anyone? That's it. Okay, fine. see, we can solve this problem using like equations of motion or work energy theorem, right? So I will do it using work energy theorem. So work energy theorem is, so initially the object is here, mass of the object is 10 kg. What is initial velocity of the body?
0.
So it falls through a vertical distance of how much?
80 meters.
80
meters.
80 meter.
Here velocity is v, we have to find. So in this question, what are the forces acting on the body?
Gravitational force.
Gravitational force, normal force. Gravitational force.
First is gravitational force, then is there any other force?
No, sir.
No, sir.
No, sir.
Normal force,
Normal force.
is it there or no?
No, sir.
No, sir.
No, sir.
Very good. There is no normal force. Why? Because the body is not in contact with any surface. So here I am applying work energy theorem. W net is equal to change in kinetic energy. Since there is only one force, W net is equal to W gravitational force, that is weight, mg. So work done by weight is equal to Ke final minus Ke initial. Let's look here. Here, what is the displacement of the body?
80 meters, sir.
80 meters, sir.
Anyone?
80 meters, sir.
Complete answer. Anyone?
8 minus 80 J cap, sir.
Very good.
Minus 80, sir.
Very good. Displacement is how much? Minus 80 J cap. Next. What is weight? Here. Weight is in which direction? So the force due to weight is minus mg J cap, right? So work done by weight is minus mg J cap dot minus 80 J cap, right? So what is m? 10. So minus 10 into 10 J cap dot minus 80 J cap. So we get
800 J cap.
Yeah. So 80 into 10 power 2. What is unit of work done?
Joule, sir.
So very good. So we get 80 into 10. See, this J is direction. Guys, this small j is direction. This joule is unit of work done. So we got WmG as 8 into 10 power 2. Next. So what is initial kinetic energy?
0, sir.
0, sir.
Initial kinetic energy is 0. What is final kinetic energy? Half mv square. We have to, so half into m into v square, half into 10 into v square, which is 5
5 V square.
v square. So what is Ke final minus Ke initial?
5v square.
So I got work done by mg as this much. So I have to substitute this here. Here Ke final minus Ke initial. So I get 80 into 10 power 2 is equal to 5v square. Can anyone find v? So V is 40 meter per second. So this problem can be solved using equation V square minus U square is equal to 2as. What is U?
0.
0.
0, sir.
What is acceleration?
V
G.
minus U by T, sir.
Minus Gj. Acceleration is downward direction, so we have to write it as minus Gj. What is displacement vector?
Minus 80 J cap.
Yeah, minus 80 J. We have to substitute this here. So we get V square is equal to 2 into 10 into 80. So answer is 40 meter per second. Any doubts? So we have this formula, right? V square minus U square is equal to 2as. What is the condition for using this formula?
When the acceleration is constant, sir.
Wonderful. Anyone else? So we can use this formula only when
Acceleration constant.
very good. Acceleration is constant. So if acceleration is not constant, how to solve this problem? No.
By
Which formula we
integration
have to
method,
use?
sir.
Yeah, very good, integration. Over.
Yes, sir.
Yes, sir.
Yes, sir.
Next. Same question. Same question. Remove neglect air resistance. If air resistance, so minus 40 into 10 power 2 joule. So 40 minus 1. Solve this question now. Take 5 minutes. See here, you cannot use equations of motion. That is V square minus U square is equal to 2as. You have to use work energy theorem. Do it.
Sir, 30 meter per second.
meter per second.
Anyone? Come on, guys. Answer?
Sir, 30 meter per second.
Wonderful. Anyone else? Anyone else? Very.
Sir, how, sir?
I'll do it. I'll do it. I'm waiting for. So here we have to use work energy
Theorem.
So work energy theorem is net work done is equal to change in kinetic energy, right? So the ball falls from a height. So the ball falls through a vertical distance of 80 meters. Initial velocity is 0. Final velocity is v. So in this case, how many forces are acting on the ball?
2 forces.
2 forces. Everyone.
Yes, sir.
2 forces.
So one is weight, another one is
Air resistance.
air resistance. guys, you should be able to identify number of forces acting on the body after reading questions. Okay, so you will learn this after doing like after some, okay, after like gaining some experience. Gaining some experience means you have to gain experience, you have to practice problems. So by practicing problems, you will be able to identify how many forces are acting on the given mass or object according to the question. Is it clear? So net work done is work done by weight plus work done by air resistance. So I can write work done by weight plus work done by air resistance is equal to KE final minus KE initial. KE final is 5V square. KE initial is
0.
0.
what is work done by weight? mg
80 into 10 to the
800.
Yeah. So anyone want me to do it again? Please type it in the chat box. I will find it for you. Again, I will do it again. Work done by weight. So work done by weight is 80 into 10 power 2. Work done by air resistance is minus 35 into 10 power 2. So we get 45 into 10 power 2 is equal to 5V square. V is 30 meter per second. Okay. Please note it down. I'll erase this.
Sir, I can't able to understand, sir. Please
Oh,
repeat once again.
yeah, sure. Look here. Nice. Okay. So if you don't understand, please ask me. Don't hesitate. So is this first point clear?
Yes, sir.
This is what is this theorem?
Work energy theorem.
Work energy theorem.
Very good. So how many forces are acting on the body? Two forces, right? Is it clear? Weight and air resistance acts on the body. Not clear?
Yes, sir.
So see here we have to find net work done. Okay. So what is net work done? Net work done is sum of work done by all the forces. So here, so net work done is work done by weight plus work done by air resistance. Very good. So we already found out work done by weight as how much?
80 into 10 power.
No, that part.
80 into 10 power 2.
Do you want me to explain this again? Hello? Do you want me to explain this again?
Yes, sir.
Okay, fine. Look here. So what is work done by weight? What is work done formula? F dot work done by a force is?
F dot S, sir.
Yes. Force dot displacement.
Displacement.
Is this formula clear?
Sir.
Yeah.
Yes, sir.
Yeah. Now look here. Here, what is our force in work done by mg? What is our force?
Gravitational.
That's weight. Okay. So here, force is weight, that is mg. So we have to write it as vector, which is minus mg j cap. Is this point clear?
Yes, sir.
Sir.
So now what is displacement? See, the body is falling downwards. So direction of the displacement is
Downward.
downward. So I'm writing minus j.
Minus j cap.
Magnitude is
80s.
80. Minus 80 j cap. So substitute minus 80 j cap here. Is it clear? So m is 10. Gravity is 10 into 80. I get 8 into 10 power 3, right? Yeah, 80 into 10 power 2. I get 80 into 10 power 2 joule. This is work done by weight. So we have to substitute this work done by weight where here. Is it clear? So here this is work done by weight. So work done by air resistance is already given. How much? Minus 35 into 10 power 2. So I substituted this here. So 80 minus 35 is 45 into 10 power 2. Initial kinetic energy is 0. Final kinetic energy is half mv squared. If I substitute m as 10, I get half 5 v squared. So by solving this, I get the final answer as v as 30 meter per second.
Yeah, sir, it's clear for me, sir. Excuse me, sir. Excuse me, sir.
So answer is 30 meter per second. Next question is a mass.
Sir, your voice is so low, sir. It's not audible.
So next question is an object of
Excuse me,
mass.
sir.
So next question is
Sir,
an
your voice
object
is
of
not audible, sir.
mass m,
Sir, your voice is very low.
an object of
Your
mass
voice is not audible for me, sir.
10 kg falls from rest through a vertical distance of 80 meters through a vertical distance of 80 meters So an object of mass 10 kg falls through a vertical distance of 80 meters. If it attains a velocity of, say, velocity of 20 meter per second, what is the how much work is done by the air resistance? Do this. So take 5 minutes and try to solve this.
Sir, work done by R is 60 into 10 to the power 2, sir.
Work done by,
R resistance 60 into 10 to the power 2, sir.
are you sure?
Yes, sir.
Fine. Anyone? Any other?
Sir, minus 6 into 10 power 3, sir.
First answer is 60 into 10 power 2. Second answer is minus 6 into 10 power 3. Any other answers?
No, sir.
I will wait for 3 more minutes.
Sir, minus 60 into 10 to the power 2.
Third answer is
Sir, minus 6 into 10 power 3, sir.
And minus 16 to 10 power
minus 6 into
10 power 2, sir.
anyone? 2 minutes left.
25 into 10 power 2, sir.
How much?
25 into 10 power 2, sir.
10?
25 into 10 power.
Okay, 20.
Minus
Minus?
minus 60 into 10 to the power 2.
Okay, minus 60 into 10 power 2. Anyone? Last 1 minute.
Sixty into 10 power 2.
Last 1 minute.
Sir, minus 60 into 10 power 2 joule.
Okay, okay. Last 30 seconds.
$60, sir.
Stay.
Minus 6 into 10 cubes, sir.
Minus 6, single number 6, right?
Yes, sir.
Minus
6 into 10 to the power cube.
2 or 3.
10 cubes, sir.
20 into 10 power 2, sir.
Sir, 12 into 10 power 2 joules.
Okay, okay. One done. 20. Last 10 seconds. minus 6 into 10 power. Signal is not clear. I can hear something. With Laika, please mute yourself. Amlata, 10 power 3. Wonderful. So only 10 power 3 or 6 into 10 power 3?
Minus 6 into 10 power.
Very good. Okay. Time up. So net work done is change in kinetic energy. Here we have two forces. One is weight, another one is air resistance. KE final minus KE initial. Work done by weight is 80 into 10 power 2 from previous question. Work done by air resistance, we have to find what is final kinetic energy. So body falls with initial velocity 0 meter per second, falls through a vertical distance of 80 meters, then and attains a velocity of how much? 20 meter per second. So final kinetic energy is half mv square. So half into 20 square, which is
20 into 10 to the power 2, sir.
how much? 20 into 10 power 2. Okay.
Sir.
20 into 10 power 2 joule minus 0. So work done by resistance is how much?
Minus 60 into 10 power 2 joules.
Minus
60 into 10 to the
10 power 2 joules.
So if anyone have doubts, please use chat box. Nice. Yeah. So next. So final kinetic energy. So final kinetic energy means final kinetic energy is half mv square. Okay, so there v is final velocity. So final kinetic energy is equal to half mv square, where v is final velocity. So here what is the final velocity? V is equal to 20 meter per second. So mass is 10 kg, V is 20 square. I get 5 into 20 power 2 So this can be written as 5 into 4 into 10 power 2. 20 power can be 2 can be written as 4 into 10 power 2. So we get final kinetic energy as 20 into 10 power 2 joule. Is clear?
Yes, sir.
Nice. So next, potential energy. What is it? Potential energy. Anyone, what is potential energy?
The amount of energy required to move the object from point A to B. Sir.
See, this
Energy
is
possessed by the object, sir,
very good. Energy possessed by the body.
with respect to its configuration, sir.
Wonderful. Possessed by the body. By a body. See, due to its position, or configuration. The possessed by the body due to its position or configuration is called potential energy. Suppose a block is attached to a spring. If it compressed or elongated, it possesses elastic potential energy. Okay. Then suppose if you take a stone and release it from certain height, okay, so it falls down, right? So as it falls down, velocity increases. So that means as it falls down, kinetic energy increases, right?
Yes, sir.
Where does this kinetic energy come from?
So the potential energy converts into kinetic energy.
Yeah. So when we take block to a stone to a certain height, it gains some potential energy. So when we leave it from here, as it falls down, it loses potential energy and it gains kinetic energy. So regarding the potential energy, it is defined to, see, this potential energy is defined for conservative force. For a conservative force. So tell me, what are the different types of what are the conservative forces?
It does not depends upon the path.
That's correct. Example, not definition.
Gravitational force.
Gravitational
Very
force.
good. Then
Electrostatic
Spring force.
Electrostatic force.
wonderful.
Spring force.
Spring force.
So all these forces are conservative forces. All these forces, see, so we can use potential energy. So all this, so suppose if you take gravitational force, gravitational potential energy is associated with it. If you take electrostatic force, electrostatic potential energy is associated. If you take spring force, spring potential energy is associated with it. So generally, potential energy is given by delta U, which is final potential energy minus initial potential energy is equal to minus integral R initial R final F dot dr. See here, this F is conservative force. See, don't worry about this integral. We are not going to use this now. This F is conservative force. This delta U is change in potential energy due to this force. Okay. So I can write that. So work done by conservative force is minus delta U. Is it clear? Suppose work done by weight. So weight is a gravitational force, conservative force or not?
Conservative force.
Yeah. See, weight is a conservative force. Why? Because gravitational force is nothing but weight, mg. So I can write minus delta U of gravity. Is it clear? What is delta U? Change in gravitational potential energy. Delta U is change in gravitational potential energy. Right. So remember these points. Potential energy can be defined only for conservative forces. Potential energy depends on frame of reference. Relationship between gravitational conservative force and potential energy is given by F is equal to minus du by dx. Please note it down. This is very important. So guys, do you have any idea on differentiation?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Everyone, please write it in chat box. If anyone doesn't have idea, please write it in chat box. Since maximum people know it, I will skip differentiation. Directly go into this. So, okay, time up, right? So guys, do you have any doubts until here? Anyone? Anyone have doubts?
No, sir.
No.
சார் நீங்க தமிழ்ல டீச் பண்ணீங்களா சார்?
Tamil, you know, பேசிட்டு சரியா தெரியாது. I don't know complete Tamil, but I can understand Tamil.
ஓகே சார், தமிழ்ல பேசினா கொஞ்சம் கம்ஃபர்டபுளா ஃபீல் பண்ணலாம்.
So okay. So good night. See you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.